Hi, welcome to my YouTube channel. Today I'm going to show you how to use MATLAB in solving real world problem. Let's take a look of this example. Okay, 1,000 tickets were sold in a certain program. 1,000 tickets were sold. An adult ticket cost $8.50 and children's ticket also cost $4.50. Okay, and the total of 7,300 was collected. Okay, and how many tickets of each kind were sold? So here we don't know the number of tickets sold, you get it, but when you add those numbers together, this is the total number of tickets which were sold. Do you get it? And then we don't know that number which caused this, and the adults number of tickets that caused this, and also the children number of tickets that caused this. In all total, when I multiply that number to this and the number to that, I have to get this thing being collected. Do you get it? How can you use MATLAB in solving this problem? Let's go straight to our MATLAB application. So this is our MATLAB application, and this is the command window. And in this window, whatever you typed comes out. So it's garbage in, garbage out. Assuming I typed 4 times, or 48, okay, times 4. It just gives me the answer straight. So it's a command window. Whatever you command this window to do, it comes out. You see, and straight down here, you will see that this is the workspace. So the answer has been stored in this workspace. So in this workspace, whatever we does here as a stored value comes here. Okay, and this is our current folder, the folder in which you want to save all your files in. It can be displayed at this portion. This is our current folder. Now let's try to clean this by clearing. So CLC to clear. You see, it has cleared all my command window, but the answer is still there, so I have to clear the answer. So I have to use the word clear all. So if I clear all, you see it has vanished. I say CLC again, it goes. Now let's go straight to our new script. So the program I'm come to run, I have to use the new script. Okay, I double click, then it comes. This is my editor face. Okay, it's untitled. So this is the place you program, then you run, and it comes to the command window. Then you see it at the workspace. Now let's try to program our situation. Sorry, let's clean this. So we are coming to program. But in program, we need to know some few steps, okay, in order for us to go by this. In programming of MATLAB, we use this as the percentage sign as a comment. So we have, first of all, you have to set, okay, a symbolic system variable. Okay, comma using. So using the keyword. So we use the keyword small m y small s y m s. Okay, sorry, s y m s. Okay, so this is a keyword we are going to use to set the symbolic system variable into this. Again, our next step here is to initialize. Okay, we initialize our solution as equation. by naming it as equation 1, okay, and equation and equation 2. Okay, so we initialize our solution as equation by naming it as equation 1 and equation 2, and our next step here is to use so we use let's bring the comment. If you don't bring the comment, the MATLAB read it as a test. So using the keyword, so the keyword, so use the keyword solve to solve the whole system of equation which we numbered them. Okay, so we use this one to solve it, and then the next thing we'll do is to obtain our solution, we need to initialize. Okay, we need to initialize the whole equation we need to initialize the whole equation by a name. So the name, you choose that name, okay, by a name. Do you get it? And so by name and together with a dot. So basically, to obtain the solution of the system variable x and y, so we need to initialize the whole equation 1 and 2 together with the keyword solve to a certain name. That name, you will choose it, and together with the dots, and then you press enter, it will come. Now let's go straight and program. So I set my symbolic variable with this keyword s, y, ms. Okay, so x and y. I use x and y. Okay, if we can go straight to this one, x and y. Now, so let x represent the adult tickets and y represent the children's tickets. So let's try to write this thing in the form of simultaneous equation and see how our this thing will behave. Okay, I want to deduce the parameters. So the first one, I denote the first one as x. So I extract this information from the application. So x plus y should be equal to what? 1000. Okay, and then we have 8.5 times 8.5 x, okay, plus 4.5 y should be equal to what? 7,300. Okay, basically this is what I deduce from our application question. So you can see that the number of tickets is x, so x by this plus y by that should be equal to this, and at the same time x plus y. So x and y represent the numbers of tickets for both adult and children. Okay, so this is how it behaves in terms of system of equation or simultaneous equation. So now, to use MATLAB to program this, always make sure that this 1000 stands alone and 7,300 stands alone. Then you move this across the equal to sign, also move this one across the equal to sign. Likewise, 8.5 x across the equal to sign plus 4.5. This this also will be moved to a 2 or across the equal to sign. Okay, now let's go straight to our MATLAB application and deduce that. So we have set a symbolic system variable for x and y. So I come here first. They said what? Initialize your solution as equation by naming it as equation 1 and equation 2. Because it is 2 equation, I have to name it equation 1. So the first equation is equation, that's equation 1, should be equal to, and I told you that from here, I told you that you let the 1,000 stands alone and you move the rest across the equal to sign. So this is how it behaves in the MATLAB. So the programming behaves this way. So the 1,000 is being kept constant, okay, then minus, when I move the x is minus x, then minus y, then I suppress it. I come here, equation 2, I do likewise, that's 7,300, okay, minus 8.5. In MATLAB, when you are times, you need to use the asterisk sign, times x minus 4.5 times y. Then I suppress that one also. So this system of equation, I deduce it from the data I extracted here, and this data is gotten from the application questions. Do you see that? So now let's go ahead and program. So we are done with this initializing. So let's come to step 3. They say using the keyword solve. So I'm going to use the keyword solve to solve these 2 equations, equation 1 and equation 2. Okay, so solve. A solve 2 is a function on its own. Okay, so solve equation. So you see, it has displayed number of them. So I'm picking the first one. So solve equation 1 together with equation 2. Okay, then I suppress it again. So basically I'm going to solve, like a keyword solve is going to solve, the MATLAB is going to compute the value for x and y by solving equation 1 and 2 simultaneously. Okay, then again, to obtain my solution or our solution, we need to initialize the whole equation and naming it together with a dot. So this whole equation, let's name it, let's say solve equals solve. What I mean is that this should display this information, okay, but the keyword is the one you have to note of. So the keyword is important. So the keyword is going to solve this, but the outcome will be stored where? The soul. Okay, I want it to be different from the keyword. Now let's go ahead and run this program and see what will happen. So wait till you start running, it will tell you to file name and save as typed. Okay, file name, let's name it simultaneous, okay, then dots, they say save as type. So this is a MATLAB, so maths, that's M, so you have to add M to it so that the MATLAB will understand. And let's save it at the desktop. Okay, then save. Alright, then we add it to the path, so it will add it to the path. So you could see that this place has come as a pause, is recognizing the system, and we will be seeing the output here. Okay, so when you come to the command window, you can see that this has appeared. Okay, so you see that this has come, the green button has come. You can see that what I did here has appeared at the workspace. So equation 1 by 1 symbolic, so it contains a symbolic variable. Equation 2 also contains symbolic variable, and the solve also contains that this two system of equation 1 and 2 is being stored here, and the x and y are symbolic variable. Now let's go ahead to obtain the values for x and y. They said we use together with a dot, so this sol together with a dot. So that's what I'm going to do. So sol dot, that system of variable, equal to, so it has displayed the value for x. Okay, let me enlarge the display so that you see it clearly. Then let's do same for y. It has displayed the y. It means that the number of tickets for adults should be 700 tickets, and the number of children's tickets sold should be 300. Now let's check our equation. It means that if I substitute the x value, that is 700 plus the 300, I'm going to get 1000. Okay, and if I do this too, I have to get 7300 as the cost. So the number times the cost plus the number times the cost should give you the total cost. So now let's check whether we will get exactly 7300 using the same MATLAB. So we come to the next line. So 8.5 times our 700, the x is 700, plus 4.5, okay, times 300. Okay, let's check. So it comes exactly as the total cost. You see, so it means that the number of tickets for adults should be 700 and that of the children should be 300. So this confirms that our program here is really correct. Thank you for watching this video. I hope you find interest in programming with MATLAB, and I want you to subscribe to my YouTube channel, and don't forget to hit the bell and drop your comment below. Thank you. Have a nice day.